Welcome to the boss level. You're in the Cambridge Igcse Physics practical exam. The clock is ticking, and if you don't know the exact attack patterns the examiner is looking for, you're going to lose grade boundaries, and fast. But if you know the code to crack these data questions, absolute guaranteed victory. Let's dive right into this explainer and crack that code.
Okay, picture this. A student sets up a simple pendulum. They pull back the metal bob, hit start on the stopwatch, time exactly one swing, and proudly write down their carefully measured answer. And boom, they just lost 3 marks, just like that. So what exactly went wrong in such a simple setup?
Well, here's the fatal exam error. They only timed one single oscillation. And this right here is exactly why ordinary revision completely fails you. You know what a pendulum is, right? You know how to use a stopwatch, but standard revision doesn't teach you how the examiner actually allocates marks for accuracy. The mark scheme demands precision. When you time just one single swing, your human reaction time, starting and stopping that watch, creates this massive percentage error compared to the tiny time of the swing itself. Look, we're not cyborgs with perfect reflexes, and the examiner knows it, so they penalize it, and they penalize it hard.
So how do we beat this boss fight? You need an unbreakable defense. Enter the high mark answer framework. Whenever you're staring down a practical data question, do not just casually write out what you did in the lab. Follow this exact 4-step sequence. Step 1, concept. What's the physics principle at play here? Step 2, evidence or data. Point right to your specific measurements. Step 3, scientific reasoning. Give them the why behind your method. And finally, step 4, examiner wording. You've got to package it all up using the exact terminology that red pen is desperate to see.
Let's put that framework to the test right now with a spot the error challenge. Check out the left side. Use a stopwatch to time the pendulum. Oh man, that is your classic vague student answer. It totally ignores the accuracy requirement. Now look at the right. Time 10 oscillations, divide by 10 to find average period t. Boom, that is an elite top band answer. It locks in those method marks because it uses our framework to explicitly show how to improve accuracy by measuring a longer time interval.
But hold on, before we even touch a calculator, we have to lock down the exact Cambridge terminology. Take the period, right? Capital T. It's the time for one complete oscillation. But you need to pay extremely close attention to the actual path. It goes from the starting point A, swings through the center O, out to the other side B, back to O, and finally back to A. A massive mistake I see all the time is students thinking A to B is one oscillation. No way. If you start at A, one full oscillation means you got to come all the way back home to A.
Okay, so once you've successfully grabbed the period, calculating the frequency is your secondary target. Frequency, lowercase f, is literally just 1 divided by the period t. It's simply the number of complete oscillations per second. It's a really easy secondary calculation, but in the pure heat of the exam hall, you absolutely cannot afford to mess this up by flipping the formula or slapping on the wrong units. That is an unforced error we just do not make.
If there's literally only one thing you burn into your brain from this whole explainer, make it the number 10. 10 is the golden rule for reducing uncertainty in your practical data. Whether you're finding the period of 10 pendulum oscillations to average out, or grabbing 10 ticks on a ticker tape timer instead of just one single tick, scaling up by a factor of 10 is the ultimate examiner-approved cheat code for accuracy. It completely dilutes the impact of your reaction time.
Now, in just a moment, I'm going to show you the exact examiner clue that changes your entire answer completely. Seriously, it's a game changer. But first, you need the framework that makes that clue completely obvious. Stick with me here, because if you bail out now, the harder data questions are going to completely blindside you.
All right, let's escalate the stakes a bit. What if the time interval is just way too short for a human being with a stopwatch? What if we're not dealing with nice, slow pendulums anymore, but we're measuring the high-speed motion of free-fall terminal velocity, or the speed of sound? When an event happens in literal milliseconds, your reaction time doesn't just give you a tiny percentage error, it completely trashes your data.
And that brings us to the precision timing tools you absolutely must be able to name drop in your exam to prove you understand short time intervals. You can't just scribble down, use a clock, when you're dropping a ball from a roof. You need to specify exactly what high-tech gear removes that faulty human reflex. We're talking digital clocks triggered to start and stop by electronic signals from a microphone. Or photo gates, or ticker tape timers, which are absolute lifesavers for motion experiments. Or motion sensors hooked up to data loggers. Knowing exactly which high-tech tool to deploy is literally half the battle won.
Okay, let's step into the examiner's shoes for a second. Imagine holding that dreaded red pen hovering over a test paper. Why do students consistently bomb the data analysis sections? Well, that red pen is basically magnetically drawn to three fatal flaws. First up, rounding too early in multi-step calculations. It throws your final answer completely off track. Second, missing units, a totally unforced error. And third, vague explanations. Saying something like, the graph goes up will get you exactly 0 marks. You've got to be specific and use that scientific framework.
Let's actually test your mental reflexes right now with a rapid pause and predict challenge. How many significant figures are in 7.180 centimeters? Seriously, take a second, pause, and lock in your answer. Getting this wrong is a silent killer in calculations. It routinely drops students down an entire grade boundary without them even realizing it.
All right, let's see how you did. If we look at some standard measurements, 2.5 centimeters, that's 2 significant figures. 5.32 has 3. But what about our challenge question? 7.180 has exactly 4 significant figures. Trailing zeros after a decimal point absolutely count. But you've got to watch out for the trap. 0.042 centimeters only has 2 significant figures because those leading zeros, they do not count. If you crunch your pendulum data and round it to the wrong number of sig figs, kiss that final accuracy mark goodbye.
To guarantee this never happens to you, you need a foolproof mental checklist to run through right before you submit any calculation or table. This is your final accuracy checkpoint. 1. Check your units. Are they actually there, and are they correct for every single value? 2. Check significant figures. Do they properly match the precision of your raw data? And 3. Check your graph scale and anomalies. Does your graph scale take up at least half the page? And did you spot any wild data points you can exclude them from your averages?
But here is the brutal truth. Knowing this practical framework, memorizing all those precision timing tools, and even mastering significant figures, it's still not enough if you fall for the final trap. Your brand new bulletproof defensive framework is totally useless if you misinterpret the specific instructions hidden right inside the question itself.
That's because the next boss fight requires cracking the command words. Remember those examiner clues I hinted at earlier? They're hiding in plain sight right at the very start of the question. Words like describe and explain demand completely different attack patterns. If you describe an experiment when the examiner explicitly asked you to explain the underlying physics, you are getting 0 marks, even if your physics knowledge is absolutely flawless.
To secure that top grade boundary, you just cannot afford to guess what the examiner wants. You have to know the code. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Our next explainer on command words is your mandatory next step to finally beating the Cambridge physics exam. Are you going to be the student who loses a grade boundary over a trailing zero? Or the one who cracks the code and wins the boss fight? Click the explainer on your screen right now, and I'll see you there.